Hi, it's Graham Cox here, co-founder of OptiSurface, and I'm going to quickly take you through a case study we've recently released looking at contour bank designs on a center pivot field in Zambia. The basic situation was that they had a field that they had developed and were experiencing erosion problems, and this is what the topography looked like originally. See, there's quite a bit of fall, 21 meters of fall over the height of the pivot, or the length of the pivot. And you can see there are some rough areas here that must have been left over after the clearing operation, maybe. So the first step was to smooth that topography out using our landform design tool. OptiSurface 4-way surface was used, and you can see that this is the existing topography, and then if we drag this across here, that's proposed, so it's just smoothed out all the contours. This is the cut fill map to achieve that. So these areas red to yellow were cut, the soil was cut, and then the blues were fill areas. So basically it's just cutting those little high points that were left. They may be natural also, I'm not sure what was causing them, but basically smoothing them out so we have a nice smooth surface to work with. Then the next step is to run our runoff analysis over the field, which is basically puts a storm event, a rainfall storm event on the field. And here we used a 1 in 10 year storm, which is typical for designing contour banks. They're designed to handle 1 in 10 year storms. So for this location, we asked the client what typical rainfalls they get in 1 hour, every 10 years. So it's a decent, event. And then in 24 hours, how much would they get? So the numbers we got were 60 millimeters and 160 millimeters. So those numbers go in here. The storm event is only simulated for 1 hour, but it incorporates these intensities even down to 15-minute and higher intensities than this, using an algorithm that I developed. The runoff is 75%, so we assume that 75% of the rainfall becomes runoff, which is typical for a high intensity rainfall event like this. Roughness 0.02 equates to basically bare soil without any vegetation on it, so it's a worst case scenario. And there's no furrows or beds. So we click that, calculate. It takes a couple of minutes to calculate typically a field like this, and then we get a results back like this which show us the rainfall depth, the runoff depth, and the velocity. So these little arrows are, let's see if we can zoom in here a bit more. Sorry, this isn't zooming in. So to zoom in, there we go. So that's the arrows that you can zoom in on. And if we go back, when the velocity starts to get above 0.5 meter per second, that's typically when we start to see erosion happening. Now it can happen a bit earlier and a bit later in different soil types and ground cover. If you've got grass ground cover, it happens a lot higher, up in the more than 1 meter per second type of thing. But if you're talking about bare soil, typical soil conditions, we start to see it around this 0.5 meter. In cultivated soil, because that makes it more erosion prone. So yeah, generally around this area here, somewhere around here. So what this is assuming that there is a drain around the outside, stopping water coming in from outside the field. So a perimeter drain, and then water rainfall falls on the field, and then as it flows down the field, it starts to build up in depth and velocity. Now, it's pretty shallow up here. We're only talking about 20-40 millimeters deep. In fact, it's all brown there. So relatively shallow, but that will kind of build up in some localized areas and create rills, and that's kind of what happens here. So we can see here that at this point we're transitioning from about from the 0.5 meter per second here into something higher. So what we do is we say, okay, well, let's put a contour bank in here to stop that water building up and take the water along a contour bank, which is a graded, there's a slight grade on the contour bank, so the water will run down, hit the contour bank like this and travel to the edge of the field where it's discharged into a grassed area to handle that water. Same, this is traveling this way. So the basic steps is to start this contour bank design using a menu selection. You select basically the slope that you want that contour bank to run on, and its typical is 0.15% for a contour bank. And then we slope, we're going up, so he must have, well, normally you'd go down, you click down here and you'd click here and it would run. You click twice actually, you click once and then you click the direction you want to go, and then it'll basically go down at 0.15% in that direction. And same here, you click it here and then you click it again, and then, sorry, you click here and then you click here and then you click the second point in the direction you want to go, and then it'll create this line on this slope based on the topography. You can see here we're using the proposed topography after we've done the landform to do that calculation on top of. 10 meters is how often it calculates a point along this contour bank. And there is a tolerance, so we can kind of smooth this out if we're happy for this line to basically be as straight as possible within a tolerance, then it does that. Otherwise it can kind of, if we make it too tight and the surface is rough, then this can get a bit zigzaggy. So that's what that does. But because we've designed this field with landform design previously, it's quite smooth anyway, so that wouldn't really matter. And then if we look at the profile along that line there, you can see that the red line is the existing topography. The blue line is the proposed topography after we've landform designed it, and then the blue line, the contour bank follows that proposed topography down. So you can see it's basically a straight line on that 0.15% slope heading here. Same thing on this side, we've done that, it goes off the other side. And then once we've done that, we basically say we've handled this area up here with the contour bank, handled this water coming in here, and then the next step is to rerun the runoff analysis over the downstream portion of the field. So we've basically drawn a new boundary for our runoff analysis in this area that's indicated by this yellow polygon, and then we recalculate the runoff analysis with these same parameters here. Click OK and calculate again. I will be selecting a different boundary because we'll be calculating on a different boundary. B1 is the boundary for the whole field, then we'll select the new boundary we've just drawn, that yellow polygon, and so it's B2. Then we'll calculate, click calculate, and it'll calculate again. Yeah, it was called B2. You can't see it there, it was B2. So then you calculate it, and you'll get another set of these lines, another set of results. You draw the polygon, the contour bank where we transitioned the yellow area here, and then you repeat the process, put another polygon down here for this area here, recalculate, And yeah, so that's the third contour bank being drawn. And then we do the runoff analysis again. You can see here, and you can see that that doesn't build up enough to the yellow. So we're right there. We only need 3 contour banks. So the benefit of that is that we limit the number of contour banks within a field to the absolute minimum, so we don't have to maintain and farm over as little as possible over banks that, you know, smallest number as possible. Now the height of these contour banks and the design of them needs to take into account the cross section, the area upstream of it, the catchment area upstream. But basically, so you're taking water. Yeah, the catchment for this contour bank was where we split it here, and then that water feeds in and discharges here. This is what the design looks like. The black lines of the contour banks overlaid on the proposed topography. So there you go. That's how we use our runoff analysis feature and contour bank design feature in our software to design contour banks for erosion control in the most scientific method available. We offer this as a service where you send us your topography and we'll design it for you based on these methods. Or you can get our software and do the design yourself if you wish. Simply click on this yellow button and we can get started. Okay, thanks for watching, and if you have any questions, don't hesitate to contact us at support at OptiSurface.com, or phone us with from our numbers found at the top of the screen. Okay, thanks for watching. Bye.